So step 8 takes the 3-phosphoglycerate and turns it into 2-phosphoglycerate. You can see that these two compounds are isomers. All right, let's draw 3-phosphoglycerate again. Now we're just going to take this phosphate group and this OH group and we're going to switch them because these two are isomers. This is a two-way reaction because only steps 1, 3, and 10 are one-way in glycolysis. So let's just switch these two and redraw the molecule. Now our phosphate group is on 2, and our OH group is on 3. Our OH group is on 3, and everything else stays the same. Well, home stretch, everybody. Again, I want to point out that when you see ATE in the name of a compound, that means you have some form of carboxylate ion, which is a C double bond O and a negatively charged oxygen. 2 more steps. So far we've done the glucose. We've added a phosphate to make it glucose 6-phosphate. We turned it into its isomer fructose 6-phosphate. We added another phosphate, turned it into fructose 1,6-bisphosphate. We split that compound into DHAP, S stands for split, and glyceraldehyde 3-phosphate. And then the C in chef stood for convert. We converted the DHAP into glyceraldehyde 3-phosphate. GAF is chef, buys 8. We added another phosphate. And then we just drew 3-phosphoglycerate and 2-phosphoglycerate. So we only have 2 compounds left. PEP, notice it has 2 lines, and I drew that intentionally because you're going to see that that has a double bond in it. And PER. And PEP, the PER stands for pyruvate. But let's look at step 9 and see if we can figure out how to draw this compound based upon the name. PEP stands for phospho enol pyruvate. Enol. Let's see what an enol is. An enol is anything that has a CH2 and that carbon double bonded to another carbon, and then an O something. So this is an enol. And in this case, with phosphoenol pyruvate, the something that's going to be here is a phosphate. Now the other clue we have in the name is pyruvate, which I tell people to memorize this way. And it makes no sense at all. It's just a fun way to remember pyruvate. Here's a pi, and what kind of a pi is it? It's a methyl pi. So we know it's a CH3. And so pyruvate, pyruvate. Well, right in the name there, you can see ATE. So you know right away you have that CO2 negative in the C1 position. Now we could also write it this way. Pi, a methyl pi, Ru, Now the ketone is not in the name. You just have to know how to draw pyruvate because it's in many, many different cycles. Pi, Ru, oops, I was going to draw it differently for you here. C double bond O. Yeah, there's our carboxylate ion. Let me redraw it here a little bit neater. There's our ATE. So in step 9, we're converting from, we're going to convert our 2-phosphoglycerate into phosphoenol pyruvate. And then we're going to convert phosphoenol pyruvate into pyruvate. So what are we up to? Let's do step 9. The last 2 steps in glycolysis. So we're going to start where we left off at 2-phosphoglycerate. Phosphoglycerate. We went from 3-phosphoglycerate to 2-phosphoglycerate, and now there's our two-way reaction. I'm going to turn that into phosphoenol pyruvate. And again, only I can abbreviate. When you draw on a test, you're going to write the name out, phosphoenol pyruvate. Well, we know it's a 3-carbon compound because once we leave sugars, everything is 3 carbons. Here's our enol. Single bond here, double bond here. It's a very sloppy single bond. Here's our enol, CH2 double bonded to a C, and then we have our something here is a phosphate because it tells us that right in the name. Phosphoenol. Now it's pyruvate. The only thing we need to add is the ATE. So I'm going to put a COO negative, which is our carboxylate ion, on the bottom. So here is step 9. You should be hearing the rush of the winner's circle by now. So now we're up to step number 10, where we turn, this is our peppers, where we turn phosphoenol pyruvate into pyruvate. So we'll redraw phosphoenol pyruvate. Here's our double bond in the name and in the structure. Remember, glycolysis, the one-way steps are 1, 3, and 10, so you'll notice I've put a one-way reaction sign in there. And here's our trick for pyruvate. Pi, Ru, Vate. Has nothing to do with the chemistry of it. ATE is telling us we have that carboxylate ion at C1. And you should know that pyruvate is a ketone, even though it's not in the name. Do you see that in between phosphoenol pyruvate and pyruvate, we've lost a phosphate group? So let's aspire to great things. Let's give that phosphate group to ADP and turn it into ATP. Now it has 3 phosphates. I want you to look at one other thing in step 10. Notice we've gone from a CH2 to a CH3. So something else that's coming in here has got to be a hydrogen ion. Where is it coming from? Well, remember that glycolysis is taking place in the cytosol of the cell, as opposed to the mitochondria, which is where Krebs cycle and electron transport takes place. And there happen to be a lot of hydrogen ions hanging out in here. So that's where this hydrogen is just going to pop on in and fill the void left by the phosphoenolpyruvate becoming pyruvate. So now I think what would be nice is if we did them all in a row, now that you're familiar with functional groups and names, and we're just going to go straight through. So let's look at step 1. This is our G in GAFAs, so we have alpha D glucose. And in step 1, we changed that G. We're going to add a phosphate group to it, and that phosphate group is going to come from ATP. Our next compound is glucose with a phosphate, so now we have, adding a phosphate, alpha D glucose 6-phosphate. Structure stays exactly the same, except this time we're going to put a phosphate group on C6. Here's our alpha, down, up, down. There's our step 1 with structures.